In this video, we're going to look at the real number system. Now, every number that you've dealt with so far in math has been a real number. You really haven't dealt with non-real numbers or imaginary numbers, which you won't until quite some time from now in other math classes. But we're going to take a look at the different types of numbers that are in the real number system. So the first number we're going to look at is an irrational number. Now, an irrational number is a number that cannot be expressed as a fraction. So numbers like that are non-ending, meaning they go on forever and they don't repeat, are irrational numbers. Those decimals that don't repeat at all, that keep going on, and you always seem to have to round. Now, on the opposite side, you have rational numbers, and these are totally opposite of an irrational number. A rational number is a number that can be expressed as a fraction. So, we have numbers like 1/2, 1/5, 5, 6, 0, stuff like that. Those are all rational numbers. They can all be expressed as a fraction. Now, within rational numbers, we have three different types of numbers. The first one we're going to look at are integers. Those are those positive and negative whole numbers. So basically whole numbers and their opposites. It also includes 0. From integers, you also have a group called whole numbers. Those are the numbers like counting numbers, 1, 2, 3, 4, and we also include 0 in this group. Now, the difference between whole numbers and natural numbers is whole numbers has 0. It includes 0 as part of their group, but natural numbers does not. These are just your counting numbers, like when we learn to count from 1 to 10 or 1 to 100. So all of those numbers you count by, those are your natural numbers. Now, we also need to look at what a counterexample is. Now, counterexample is just an example that you use to prove a statement false. So it's when you're asked, is this true or false? And if it's false, give an example. That example is considered a counterexample. You also have the definition of an inequality. And this is just a mathematical sentence that compares the value of two expressions using an inequality symbol, like the greater than, less than, greater than or equal to, and less than or equal to sign. So these signs, and sometimes we call them alligators when we're little, you know, which side the alligator is eating. These signs are used to compare two different expressions. The last thing we're going to look at is an absolute value. And this, it's a number between bars, and it's asking you, how far is this number away from 0? You'll always get an absolute value to be positive, because we always measure distance in positive numbers, never negative. So no matter what, you'll always have an absolute value as a positive number. Now, looking at the real number system, we have a chart that you can create that more describes what a real number system is. Basically, everything in this black area is a real number. Now, within this real number system that we have two groups. It can either be rational, which is all these numbers, or irrational, which is these numbers. Now, remember, your rational numbers are those that can be expressed as a fraction. Your irrational numbers are those that cannot be put into a fraction. They're non-repeating and non-ending decimals. So something like the square root of 2. If you type that into the calculator, you're going to get 1.414213, and it goes on a little bit. It never repeats or anything like that. So that one you cannot put into a fraction, so it's considered an irrational number. Also, the square root of 7, which is 2.64575, and goes on, but it never repeats, so you can't put that one in a fraction either. Now, the pi number. Pi is considered irrational only when it's not rounded. We use a lot of times 3.14 for pi. Now, if you're just given the number 3.14, that's not pi. But if you're told the number pi, or use the pi symbol, that's an irrational number. It goes on and on forever. It never ends, never repeats. So it would be considered an irrational number. Now, a number is either rational or irrational. It's never both. It can never be in both the rational and irrational groups. Notice the separation between the two squares or rectangles as you see. They're not on top of each other. That means they don't share any numbers. Now within rational numbers, you can have -10/3. That's an irrational number. Now you can also have 3 or 0.75. This is an ending decimal. You can put that into a fraction, and that's 3/4. Also 1/3. Even though putting into a decimal is 0.3 repeated, but since the 3 is being repeated, it's considered a rational number. Within a rational number, you have integers. And all integers are also rational numbers because they're sitting in the rational number rectangle. So all my integers are going to be rational numbers. So integers are like -3, -2, 1, -1, 0, 1, 2, 3, and so forth. All those whole numbers and their opposites, including 0. Remember, all of these are also rational numbers. Now, whole numbers are just from 0 onward that are counting numbers. So 0, 1, 2, 3, and so forth. These whole numbers, notice, are also on the board for integers and are on the board for rational numbers. So, the whole numbers are rational numbers and integers as well, because this rectangle is on top of these two groups as well. Now, natural numbers are just those numbers, same as whole, but remember we don't include 0. So 0 is the only difference between natural and whole numbers. Sometimes you'll hear natural numbers called counting numbers because that's how we count. We don't count by 1/2, 3/4, 1. We don't count like that. How we learn to count is 1, 2, 3, 4. We don't start at 0. So that's why we have them in natural numbers. Now remember, natural numbers are also whole numbers and integers and rational and real. Natural numbers are not irrational numbers because these two rectangles don't overlap. And all these natural numbers can be put into fractions. Like this would be 6/1, which is 6. 5/1, which is 5. They're all still fractions. Now, using this real number system, you'll be asked to classify or state the sets of real number groups that a number belongs to. When doing that, it's asking you to state all the groups that we just talked about and say which groups does that number belong to. Now this first one, we have 2/3. First thing, always real. Always a real number. Okay? The second thing, ask yourself, is it rational or irrational? Can I write it as a fraction? Well, 2/3 is already a fraction, so you know it's rational. Since it's rational, you got to keep going. Next question, is it an integer? Is it a whole number and its opposite? 2/3 is a decimal and it's a fraction, so it's not a whole number. So we're done. All this belongs to is a real system and rational numbers, and those are the only two sets that 2/3 belongs to. Now we look at the square root of 36. Now, we've got to actually figure out what is the square root of 36. Well, that is 6. So in order to figure out what the square root of 36 belongs to, I've got to think of what does 6 belong to. We know it's real. Then we ask rational or irrational. Now it can be expressed as a fraction, 6/1, so we're rational. Okay? Now, is it a whole number and its opposite? That would be an integer. And yes, this is a whole number, so it's an integer. So next I need to ask, is it a counting number, including 0? Well, yes it is, so it's also whole. And since it's not 0 and it's whole, then it's also natural. So really, this 6 belongs to real, rational, integer, whole, and natural. All of these groups. Looking at 0. 0 is real. We also know it's natural, or a rational number, because it is, in a fraction, it would be 0/1, 0/2, something like that, so it's 0. We know that's a fraction, so it's rational. It's an integer because it's a whole number or its opposite, including 0. And we also know it's a whole number because whole numbers are counting numbers in 0. Now, it's not a natural number because that's the difference between whole and natural numbers is natural numbers does not include 0. So since this is 0, we're not going to include it in that. The next one is the square root of 2. Remember, we got to figure out what the square root is. You notice it's 1.4142, and your calculator will keep going. Eventually it will end, but it fills up the whole entire screen, never repeats. So we do know it's real, but this time it cannot be expressed as a fraction, therefore it's an irrational number. Since it's irrational, it cannot be anything else. I won't write integer, I won't write whole, nothing. Since it's irrational, it's just irrational and you're done. Negative 14. This is a real number. It also is expressed as a fraction, negative 14 over 1. So it's rational. It is an integer because it's a whole number and it's opposite. Negative 14 is opposite of 14. So it's an integer. But since it is not a counting number, including 0, I cannot list it as a whole number because whole numbers does not include negative numbers. So it's just these 3 groups. Now this last one, 3.14. Now in everybody's head we're like, that's pi. I know that, that's what we normally use for pi. But this is not pi. This is pi rounded. But 3.14 is just a number. It is real. We can't put it into a fraction because we could do 3 and 14 over 100. So it's real and it's rational. But notice since it's a decimal, it's not an integer because integers are whole number and it's opposite. So 3.14 is going to be real and rational. And notice this is not pi. If it was pi, I would actually have the pi symbol. The next thing we're going to look at is using counterexamples when looking at the real number system. Now, this first example says all whole numbers are rational numbers. And this is true because remember whole numbers are counting numbers and 0. Well, all of those can be expressed as a fraction, and that's what a rational number is. So this example is true. The second one, all whole numbers are natural numbers. Remember the difference between a natural number and a whole number is 0. So if all whole numbers are natural numbers, that would be false because 0 is a whole number, but it's not a natural number. This last example, no fractions are whole numbers. Well, we do know all whole numbers are going to be rational as we set up here. So rational numbers have to be fractions. Therefore, this is going to be false because a whole number is 4. That's the same thing as 4 over 1. Well, 4 over 1 is a fraction, equaling 4, which is a whole number, but it is a fraction. So this one is false. The next thing we're going to look at is the absolute value. Now remember, this is the distance a number is away from 0. Now since we always measure distance in positive numbers, I never say I'm negative 6 miles from the pool. I say I'm 6 miles from the pool. So absolute value is never going to be negative. So this first one, I have the absolute value of 12. Now notice these bars. This is the absolute value symbol, or just straight vertical bars. So we know how far is 12 away from 0? Well, it's 12 spots away. So notice your positive numbers will always stay positive. Your negative numbers become positive numbers. So negative 3. How many spots is it away from 0? That's 3 spots. So absolute value of negative 3 is 3. Same thing with negative absolute value of negative 1/2. It's a half a spot away from 0. So the absolute value would be 1/2. Now this next one has a few operations in it along with the absolute value. So what we need to do is treat the absolute value bars almost like grouping symbols or parentheses. So I need to do that first before I do the rest of the operations. So I need to do 3 plus negative 1, and that's going to be 2. Now the absolute value of 2, how far 2 away is from 0? That's 2. So now I do 4 plus 2, which is 6. So your answer for this one would be 6. Now same thing with number 5. I need to find the absolute value of each number in the bars before I multiply them. The absolute value of 12, like we said over here, is 12, and the absolute value of negative 4 is 4. Remember, if it's negative, it becomes positive, and if it's positive, it stays positive. So 12 times 4 is going to be 48. Now comparing and ordering numbers. You used to do this way back when in 6th grade, so this should be fairly easy for you. Now when you're writing a number from least to greatest, like this, negative 3/8, negative 1/2, and negative 5/2, you want these numbers written least to greatest. Since they're all fractions, the easiest thing to do is to write them as decimals. Now, when you're writing something as a decimal and you have a calculator, all you do is divide the numerator by the denominator, which is the top divided by the bottom. So negative 3/8, written as a decimal, is negative 0.375. Negative 1/2 is negative 0.5. And negative 5/2 is negative 0.146. Now we can start ordering them from least to greatest. All these numbers are negative. So what we need to do is to see which one's furthest away from 0. Now, with all of these, the one that's the furthest away from 0 is negative 1/2. So that's going to be my smallest number since it's negative. My next one is negative 3/8. It's further away from 0 than the negative 5/12. So my answer would be negative 1/2, negative 3/8, and negative 5/12. This second one we're doing negative 2/3, negative 5/8, and 1/12. So put them in decimals. Negative 2/3 is negative 6 repeating, negative 0.6 repeating. Negative 5/8 is negative 0.625, and 1/12 is 0.083 repeating. Now, we have one positive number, so of course that is going to be the largest number. So I automatically put that at the end. It's the only positive. Then I need to look at these two numbers. Since they're negative, I need to look at which number is the furthest from 0. And that's going to be negative 2/3 because it's further away from 0 than negative 5/8. So my answer is going to be negative 2/3, negative 5/8, and 1/12. Now we need to compare two numbers using the inequality signs. So I've got 2/3 and 1/6. Well, first I need to put them in decimal form. I got 0.6 repeating and 0.16, and the 6 is repeating. Now, which one is bigger? And that's going to be 2/3. Now, with this one, negative 2, the absolute value of that, what's it going to be with 2? Well, we know from previously that negative 2, the absolute value of that is 2. Now, 2 and 2, they're the same number, so they're going to be equal. This next one, 1/2, the absolute value of that, and the absolute value of negative 0.51. Now, the absolute value of 1/2 is 0.5. The absolute value of negative 0.51 is 0.51. The larger number is going to be the 0.51. So, I'm going to have my absolute value of 1/2 is less than the absolute value of negative 0.51.